So for year 9s getting confused over their data results and the process data table and the graph, let's run through it. Most of you probably already have some sort of table which has the time intervals, the 30-second mark, the 60-second mark, the 90-second mark, the 120-second mark, and the temperature that your mixture rose or fell down to. So this is what we refer to as usually as a raw data table. That means the actual results you collected on the day. What I'm asking you to do is to go with a process data table because this gives you a more meaningful thing to use to make your graph. But before I get to that, let's go back to the raw data table. What I'm asking you to do is to try and tell me the temperature change. So at time 0, it was 22 degrees in this made-up example. And I look at my series of values of temperatures that it rose up to, and I can see that it roughly rose up to 25 to reach its maximum. Now, if your temperatures went down, I want you to pick your minimum, okay? So I'm going to select these two here. I'm just going to do a quick subtraction between the two, and the way I'm going to do is I'm going to do final minus initial. Okay, so the final temperature was 25, subtract the initial temperature is 22, and I get a result of 3 degrees, positive 3 degrees. If your temperature dropped, let's say it went from 22 and maybe like 19 and then 18 degrees, you would have 18 degrees minus 22, which will give you a negative number. The negative sign or the positive sign gives the reader a sense of whether your reaction increased in temperature or if it decreased in temperature. And if so, by how much exactly. So I'm going to take this value here, I just calculate. This is the difference in temperature of what I started and ended up with. And I'm going to place that in my process data table. It roughly works on this principle here, where I got an independent variable block, the one I'm changing on purpose, which for our students, we are doing volume increases, so 20 mils, 50 mils, 100 mils. That is the variable we are changing. The dependent variable is the effect that we're measuring or looking for, and that is the temperature change. So I've got written temperature change in my dependent variable block. You've got to focus it. Yep. And my independent variable is the volume of the reactants that I was using. So there's the 20, 50, and 100 mils. For the temperature change, we repeated it 3 times. Most of us did. I think Dean's group ran out of time and resources. So trial 1, trial 2, trial 3, and an average column underneath the heading, underneath the banner of temperature change, okay? So for that temperature change I just calculated here, I'm going to now put it into my first trial 1 of the 20 mil test. And I'll do the same process again from my raw data, take the first and the maximum out of each of them, and I'll then sequentially add it into my table of results here. This is my process data table. Now, if you've done the raw data table and it looks fine, then please, yeah, you can use it. No harm done. But if you want to make a meaningful graph, I recommend you start with, you make one of these. Do you need the raw data table? No, but it is helpful to make the value entries here, okay? If you only have a table like this, that is perfectly acceptable. So now that I've got once I've got the individual trials of temperature change for the 20 mils, I can then do an average calculation. I've already done that here and here and here. Now, when it comes to graphing, so what kind of graph we do? If you're going to do this on your computer, the graph type you're looking for is called a scatter graph. A scatter graph works on an X and a Y coordinate system. So for every point on your graph, it should have an X coordinate and a Y coordinate. That means how far across and how far up does each data point occur. If you mistakenly use a line graph, you get a bunch of gibberish. Instead of having X and Y coordinates, it'll instead go from 0, 1, 2, 3. You can always tell if somebody's used a line graph because they always start from 0, 1, 2, 3. And it's not going to make any sense. You're actually going to get you'll get 2 lines on your plot if you use line graph, which makes no sense. We want to use the coordinate system of a scatter graph to show how our independent variable relates to our dependent variable. Is it going to form a straight line, or is it going to be roughly random, or is it going to be roughly the same value the whole way across? So I'm going to take my process data tables. I'm going to take these values here, the volume of reactants that goes in the bottom axis of my graph, the independent variable. So here they are here, so volume of reactants, mils in brackets, 10 mils, 20 mils, 30 mils, 40 mils, 50 mils. I have to make sure my increments, the spacing apart for these numbers is equal. It has to be consistent, just like a ruler has to be consistent. Same thing with my vertical scale. They have to be consistently spaced apart. So 1, 2, 3, 4, 5, okay? Now, I've got these values and they're in here. So the 20 mil mark is there, the 50 mil mark is there, and the 100 mil mark, I ran out of space. It's over in this corner. We're going to take those values and we're going to graph them against the average temperature change, these values here. So that's where my temperature change scale is on the vertical axis. So my first data point at 20 mils had an average increase in temperature of 3.3. So I go from here and I go 1, 2, 3 and a bit. So here's my first data point. And then for the 50 mil volume, it went up by 3.6 degrees. So I go up to the 3 mark and that's probably roughly there. And for the 100 mil volume of reactants, it went up by 3.3 as well. So over here, it's there's my data point. So now I've got my 3 data points which reflect my 3 averages of those 3 different volumes. Now I'm going to draw my trend line or my line of best fit, and you can do this by hand. It's the line that best describes the overall shape that these data points make. Now yours might be like up, down, up. You can do a little bit of curvy thing. Remember, when you do a line of best fit, it's not about joining them dot to dot, okay? We don't do that anymore. We haven't done it since primary school. I want to see a line of best fit, okay? That is a line that describes roughly where they all are. It doesn't have to strike through the middle of every one of those data points. Let me show you another example of what it could look like. So if I've got some data points that looked, let's say I've got a graph that's shaped like this. Can you see how it's going to be nonsense if I join them all point to point? I want to have a line that best describes them. Some of them won't touch the line. That's perfectly okay. We're just trying to describe the overall shape. Is it straight, like a linear line? Is it curved? Is it cyclic, where it kind of goes up and down, up and down, up and down? We don't know. That's what you are required to show me. Hope that makes sense, guys. Good luck over the weekend. I'll see you on Monday.